All right, lesson 8.7 is about circles. We're going to be talking about circumference with circles and talking about the area of circles and looking at different formulas that we're going to be using for these things. So to first get us started, we're just going to talk about the different parts of a circle so that we can actually discuss those. From the center of any circle to the outside of it, and this can be drawn anywhere around the circle, this gets called the radius. So we also have this situation where from the center, if we go from one side of the circle all the way over to the other side of the circle, traveling through that center point, we call this the diameter. And the diameter is actually a double radius. So we have a radius going out from both sides then. The other one that's here, we're not going to work with this too much this year, but in the future you will. This one is just called a chord. And it's basically any line that cuts across the circle as long as it does not go through the center, because that's our special diameter. The last one that I have is just pointing to the outside. And what I'm trying to talk about here is going all the way around the circle, and that one's going to be called circumference then. So we'll talk about circumference in just a second here. Key concept for us, talking about the radius and the diameter. How are they related? So the radius is half of the diameter, or you could say that the diameter is 2 times the radius. So that's what you need to know. The radius is only that halfway across, but the diameter goes all the way across then. We're going to be using pi in this lesson, and your calculator that you have at home with a scientific calculator is going to have a pi button on it, but we're not going to do it. So we're going to instead use 3.14, and that'll allow our answers to be a little bit shorter. We won't have as many issues with rounding, and we'll all kind of be on the same page. So we'll use 3.14 for pi. So our first ones here, the circle is on your formula sheet, and for our area, which is what we're going to be talking about, our formula is area equals pi times r squared times the radius squared. So for all of these here, we notice we do have a circle. What I'm going to ask you to do is always check first right here from the center to the outside. This is in fact our radius. So our radius is 15. So we can go ahead, plug this in. We're going to do pi times 15 squared. And we can actually have two different answers here. So one of them leaves our answers in terms of pi, which means we're still going to have pi in the answer. Oops, not that many lines. So we're still going to have pi in our answer. And then the other one would be actually multiplying it on your calculator and getting a decimal answer. So in order to leave pi in your answer, you're just going to do the 15 squared part. So 15 squared is 225, and we're going to treat pi like it's an x almost, and we're going to put it last. So when we write our area in terms of pi, we're going to write 225 pi, and then we're going to give this a label. Our units were feet. Remember, area is coloring it in. It is a squared for that one. To get our decimal answer then on our calculator, we'll just type 225 times 3.14. And when we do that, we get 706.5, and we'll also label it with feet squared. For our next example, notice that we have the diameter because it goes all the way across. When that happens on the picture, I would ask you to write in what the radius is. The radius is half the diameter, so half of 22 is going to be 11. So area equals pi r squared. Remember, we're always writing our formula first. Pi times 11 squared. So we'll leave our answer in terms of pi, which means we'll do 11 squared. So 11 squared is 121. And then we don't forget our pi, and our units here are inches, so we're going to say inches squared. If we want to go ahead and change this to decimal form, we'll do 121 times 3.14. That'll give us 379.94 inches squared. For our last example here, we do have our radius. So the radius is 9, so area is equal to pi r squared. So we'll plug in the 9 for the r. Leaving our answer in terms of pi, we'll do 9 squared, which gives us 81 pi. And the units here were yards again, so we'll have yards squared. And to go ahead and get our decimal answer, we'll multiply by 3.14, giving us 254.34 yards squared for this one. So that's how you work with the area formula for circles. The other formula that we have is called circumference, and it's really perimeter of a circle. So circles don't technically have straight edges. You can argue that in the math world. There's kind of a whole lot of big debate that happens between there. So what we're going to do is we call it circumference instead. So the perimeter of a circle is called circumference. So on your formula sheet, you see this formula, C equals 2 times pi times r. What I do want to point out to you is if we reorder these, 2 times r times pi, 2 times the radius is actually our diameter. So we can also use the formula circumference is equal to the diameter times pi. So I will stick with this one because this is what you see on your formula sheet. But if you recognize that you can do 2 times the radius to get the diameter, you are welcome to do that. So for example number 1, we're going to find circumference. We're going to do 2 pi r is my formula. My radius here is in fact 5. So I'm going to do 2 times pi times 5. We can also leave our answer in terms of pi here, which would mean I'm just doing 2 times 5 first, which will give me 10 pi. So that's kind of one version of my answer. The other would be to do my decimal, which would be 10 times 3.14, giving me 31.4. Because circumference is a perimeter, this is just a linear, so we're just going to call it just centimeters here because it's just going around the outside. It could be done but with a piece of string. For this one, we're going to use our formula circumference is equal to 2 pi r. So if I work backwards, this is my diameter, which means my radius is actually 4. So 2 times pi times 4. 2 times 4 is going to give me 8 pi, and you can see where this formula would have saved us a couple steps here. And we can go ahead and actually multiply 8 times 3.14, which will give us 25.12, and we have centimeters as our units then. Quick little application of this for you. Reagan is making a cylindrical gift box for a baby shower she's attending. The box will look like the picture, and the radius of the circular base is 5 inches. So if we go from the middle to the outside, we're looking at 5 inches here. Everything is done except for the ribbon that's going to go around the outside of the box. What length of ribbon will she need to purchase? So length of ribbon, we're talking about circumference. So 2 times pi times the radius. So 2 times 5 times 10. That's going to give me 10 pi. When I'm actually working on a real world problem, I am going to actually want to go to that decimal answer. And my circumference is 31.4 inches. When I need to purchase whole inches, I'm going to have to purchase 32 inches of ribbon. For the last step, if it's 9 cents per inch, what's it going to cost her? So 9 cents times 32. And I get $2.88 then for Reagan's total cost for buying the ribbon to go around.